Cool. All right. So we're going to go through these one at a time. Yeah, please. So yeah, I mean, this is eventually what we're going to do together. We'll build something like this. You can see that it's not too complex. I mean, here one of the main differences, there are two master sketches, right? There's a top, and I believe this is on the right plane. But essentially, the first feature I'm going to be introducing is a sweep. And a sweep is really pretty straightforward. What it is you have a sweep is defined by two sketches. You have the profile. So in this case, it's this kind of like half circle with like a shorter arc here. And then you have the path that you want the profile to follow. So you have another sketch, and you basically say, hey, I want this shape to follow this line. It's really that simple. All right, let's go home. We're done. No. Yeah, I mean, so in this instance, like when we build this handle together, you can see that I'm sweeping only in one direction. You can control like the path, right? In this instance, I have the path as my master sketch. You can see here I did use a spline to make this, to get like a more gentle curve, right? I wanted this to come out a little bit further. I could have done this maybe with like two arcs, would have been another way to do this. But then you also you can see I'm building the handle in a half using a cut because this is where it's going to merge onto the appliance. Some basic fillets on the edges here so that it's softer, and then mirroring it. Really pretty straightforward. Good question. No, the cut is for where the handle will meet the door. So you'll notice with the sweep, right? If I show my sketches here, and actually you can see, maybe this, I'm sorry if this is a bit confusing, but I ended up elongating this sketch. It's still based off the master. I just pulled it a little bit further. That the swept profile just follows it along normal to it. So part of the reason that I elongated it here, if I go back in here and if I shorten this, if I drag this point, or instead of dragging it because it's jumping further than I want, if I select this point and select this point and tell them to be coincident, what's going to happen is the profile stops short of this line. And for me, this line represents where my door is. So now if I have the cut, you'll see it doesn't fully go through, right? Sorry, your question was the fillets for where it matches the door. So my answer is it was the cut is where it matches the door. The fillet is just for these edges, just to make it soft. I mean, I could have put this in the sketch profile. In this instance, though, I want it to be easily adjustable. I don't want the fillets in the sketch can add complication. Again, with the bottles, it was a very simple thing to say to just trace all the curves. I think, again, I would say that if the curve helps define the design, it should be in the sketch. If it's something that, and what do I mean by that? Like if the curve is iconic, right? If it's a fundamental part of the form, like what's difficult there is you could argue that this fillet is a fundamental part of this form because it's how it functions. But what's more important in this sketch is like the contour of the bottom for the hand and then how kind of flat you want the top, right? The edges don't matter as much. You can define that later with the fillet. I would also argue in general, like, I mean, yeah, and again, it's like there is no right or wrong way. You could have an argument why that curve this fillet should be in the sketch to begin with. No, I know. Yeah, I realize it as like I'm arguing myself, kind of. No, I mean, I'm just trying to explain to you guys, like, and I realize, like, again, there's no right or wrong way. I think in general, it's always, especially in a situation like this, where it's just one fillet later, the sweep is going to be more robust with having the fillet after. There's like less tangencies and things you have to worry about if you come to a point. I mean, in general, like, again, a good rule of thumb is to put fillets at the end of your model. So that kind of includes building them into your sketch, which I know that, yeah, that wasn't quite your question. But yeah, I mean, the fillet here is really just to add in on the edge. All right, so just to explain this in a little bit more detail. So the profile that you want to sweep, in this instance, I'm just going to make a circle, right? This is the shape that I want to sweep. So again, it should be a closed contour. If it's open, the sweep probably won't work. I don't know if there's a thin feature for a sweep. Like we can play around after this and see. On this face, I'm going to make, on this right plane, I'm going to make a new sketch of where I want my sweep to go. So first I'm going to illustrate, if I do it sideways like this, let's see what happens. So I'm going to select this. This is what the sweep looks like. It's kind of like a snake. So here, if I delete this, again, the circle is what the profile is. What is the closed contour that you want to sweep? So in this instance, I am sweeping a circle. I'm going to select that. This is the path, right? So if I select this path, you can see that it travels along normal to that path. Meaning to say that because this is going at an angle, you can see it has an angled start and an angled finish. Does the term normal to make sense? Like, the shape doesn't rotate. It just, whatever the orientation is on that plane, it's just going to follow that path in one smooth motion. Great question. No, it doesn't. So I'll show you that now. The path does not need to be at the center. In fact, you can have a path. Here, I'll do a spline just to make a point. You can have a path off center. Whoops. And it should work. It may not because this spline is too crazy. Let me change that. Now, I do believe that it is, let's try it with this line. So the spline was a little bit too crazy for it to pick up on that. I'll go back and play with the spline again. I tend to try and keep the swept line in the center of the profile just because then you know exactly where it's going to go. So for example here, you guys see the path and you see where it was swept? Like, it swept the shape relative to the path. So what that means is, do you see how this hook here, it's concentric to this one, right? Concentric is like the curvature terminology for parallel, the equivalent of parallel. It doesn't follow the exact value of this. It follows, I mean here, if we put in some dimensions in here, I can tell you exactly what this ends up being. So for example, if I just put a straight line from here to here and give you this dimension, I'm going to switch to inches. So actually, really, I should be dimensioning from the edge of the circle. But let's say this circle is 1 inch tall. Oh, you know what? I just broke this because this should be for construction, right? I don't want it to pick up that line. So if I make this 1 inch big, that means that the sweep line is 1.5 inches away, which means that whatever this curve is, so if this is, let's just make this 2, that means the actual hook ends up being a radius of 2 plus 1.5 inches, so a radius of 3.5 inches. Does that make sense to you guys? Can we see that? So that is why you want it to be in the middle. You want your sweep path to be in the middle of whatever profile it is that you're sweeping. It's just general rule of thumb. Now that said, sometimes you're kind of like, if you're like doing something like quick and dirty and just like trying to pull a sweep path and maybe you're referencing another part of the object, by no means do you have to like create a new path in the center of it. So here, what do I mean? Let me give you guys another example. So most sweeps look like this. It's two sketches, one's the profile, one's the path. Sometimes you will have a situation where you're working on a complex model. You have a handle and you want the handle to mimic another part of your design, right? So maybe your microwave has a curve on it and you want that handle to mimic that curve exactly. And it's 1 a.m. and the project's due, the next day or whatever. I went the wrong way with this. It is possible to have the sweep profile follow an edge of a body, is what I'm trying to say. So in this instance, I can take this sketch here. I can say, hey, I want you to sweep this. And now when it comes to selecting the path, instead of just selecting this sketch, I can go to this edge. And then I don't think I've explained this yet. Sometimes you have more selection options, right? So the gut choice to do here would be to just click on this with your left click. But let's say you want it to actually come up and around. You'll notice if I click this, it's not letting me, right? Because the edge is already selected. If I do it, okay, maybe this only works with a sketch. Let's see. When it comes to selecting edges, you can right click and say Selection Manager. And now you can select multiple edges. But it doesn't look like it's letting me sweep this from far away. So maybe this does have to be in the middle. And back to that other example I used with the spline, I think it helps. It's always going to be more robust if it's in the middle. Sometimes you can get away with this, sometimes you can't. So here, let me move this to be from the sketch plane. Sorry, guys. Oh, you know what? I think that's what I did wrong. Let's try this. So I didn't realize it was floating up in the air. And so, here, let me Control Z just so you guys can see what I think was wrong. So from this right view, do you see how the body was up above? Even though I was trying to sweep on here, I think it was having trouble jumping. Let's see if moving it down works. If not, it may have to be in the center. No matter what, when you do sweep, it's always going to be more robust. It's always going to have a higher chance of success if it is touching the profile that you're trying to sweep. So let's offset. Whoops. See what happens here. Whoops, not the right sketch. So again, if you want to select multiple things, you right click, you go to Selection Manager. Here we'll pull two edges. Oh, it may not do it. It's not happy with me. Okay. It looks like it has to be on the... Let's back it up now. Let's see if it works here. So again, select the profile. Let's see if it works now. See, that's really weird. Now it's working when it's on the same. Yeah, it might be that it has to be... Oh, see, it doesn't like it though when I select multiple. There's a very slight chance this is another point that I want to eventually make. Let's just absolutely make sure it's not this that's failing. Let's see now if this does it. Okay, so I think I wasn't quite ready to make this point yet, but may as well make it now. Sometimes what happens with a sweep is things that make the sweep fail. If the turn is too tight, if you have a curve through there and the body can't make that turn comfortably, the sweep will fail. It's kind of like the circle is turning in on itself and the geometry, like, I don't know what word to use, it like crumbles, right? Like it doesn't even do it because this profile, this 1-inch profile couldn't make that tight of a turn. And I think it was because I was at 2 inches. So like here, if I modify this, since it's based off this edge, we can keep making this smaller. So do you see how this like inner portion is getting a lot tighter? At some point, this is going to fail. Let's see if it works on 2.5. So it wasn't working on 2. And that's because, again, because we have a 1-inch circle that we're trying to sweep, when it tries to turn on this like 2-inch radius, the body basically fails on the inside of that turn. So the takeaway from this is that, specific on this error, is that whatever it is you're sweeping, whatever the size of that profile is, you want to make sure your curves are big enough that it can comfortably make that turn. It looks like with this body example that I was giving that you can sweep along edges. The other takeaway, sorry, let me start again. The other takeaway is that you can get away with having a sweep path not touch your profile, but you're always going to have a better success rate and more robustness if it does. Does that make sense? So let's see here. I don't know if this is what was failing before. I'll move this off center again and see if that's all that it was. So again, here I'm just saying, you know what? I don't want it to be on the sketch plane. I want it to be 2 inches off the sketch plane. That was what the issue was before. Okay, so it does work. Let me double check this error again. Let's see if I pull this off. I think that this will now fail because it may not have a reference point to start on. So okay, if we go through the rules of a sweep, you want the path to at least be on the same plane as that starting face. The path doesn't necessarily have to be touching the profile, but it will always be more robust if it does. And then, of course, you want to make sure the turns work. So let's try this spline again and see if we can get the spline to work if we're touching the path. Now, sometimes the other issue that may have affected the spline is like if you come off at a weird angle. Like I think this will work. We can play with it. So again, I'm going to sweep this along this spline. Do you see how funny that looks right off the bat? And again, it's because it's following it normal to it. There are some options in here that you can play with. Okay, I'm sorry, wait, here, this is the keep normal constant. So here, it's like you have this flat shape, and no matter what the spline is telling it to do, it just stays this way. You can see here it gets narrow. I'll be honest, I'm not. You know what it is, I think? This is what's happening. This is my best here. Let's keep it at this, and then I'm going to do my best to explain this verbally, like what I interpret is going on. So I'm going to pull a line here, make this tangent. Sorry. Here's what I think is going on. Because this is the angle that the sweep starts at, it takes a look at this shape. Even though this is a circle on the sketch, this is what the sweep sees, right? Because this is the trajectory that it starts on. So therefore, this ellipse becomes the shape throughout the sweep. Does that make sense? Do you guys see that? So like if I cut this perpendicular, I'm just going to judge by eye what I think is perpendicular. If I throw a cut in here at the top, whoops, we can see that that looks roughly like that ellipse of what this view looks like. So I think that's what's going on. Now the other option in the sweep here is what I explained first, which I'm sorry I mixed that up, is keep normal constant. Instead of kind of taking a snapshot of what it sees as the trajectory coming off the sweep, it just takes that circle and it moves it along that path in the same orientation that it's in. So therefore, when the path gets vertical, when it goes vertical or in the same orientation, right? So this is sketched on the top plane. So when this path travels vertically up Y, this is where this becomes more of a circle. If I use this like section tool here to cut through this, we can see if I drag, as I drag this up, Here, where the path travels perpendicular to the orientation of the original sketch, you can see it looks like the original sketch. For the most part, though, like these settings, you don't need to worry too much about. I would leave this to follow path. I typically don't mess with these options. It's also just a good rule of thumb, again, with sweeps, that where you start it, you should always start the path perpendicular to the sketch. So, assuming that the profile is exactly what you want. So in this instance, I'm going to say, hey, I want this to be vertical. And our cut failed. But now you can see our sweep is now a full circle because it started perpendicular to that. I'll be honest, I'm surprised that it's making it through this tight bend. We can play with this and see where this fails. I mean, it's the exact same thing. That the tighter this gets, the higher likelihood that this sweep is going to fail. There is a chance that splines may be more forgiving than curves. Let's see if it makes it through this. So it appears that splines are more forgiving than curves, or arcs, rather. Here, I'll be honest, I'm not sure why that is. I think splines are a little bit more, because they're less defined, maybe the CAD is like allowing the sweep to kind of get away with it. Maybe it's the way that it's programmed and it works. I mean, because with an arc, there's a definitive value to it. As that circle turns it, the rule of thumb is, so if we have a square that's like an inch by an inch, I believe that it will turn, I mean, we can play with it. Let's see. I believe it should turn within 2 inches. So let's change this profile here. Let's see, when we were using that edge before, it made it through, it's like super long line. I think it failed at 2 inches is where it failed before. Let's try it. Now, again, you also want to think about the relationships too, right? If you want the sweep to be consistent, this should be tangent. Let's see if this works. Okay. So the radius is 2 inches. Let's see if it turns through 1. I'm going to guess it won't. It does. Okay. Let's keep going smaller. Let's see if it turns through a half. So there is a chance that the edge is less robust too. So in general with your sweeps, like it's just a good rule of thumb. Like there are things you can get away with. So here it's basically a 90-degree turn, right? Because I'll be honest, I'm surprised it's doing this. So I'm mistaken. So because this is an inch in diameter, it's turning on a ½ inch radius. I think, let's see if this changes to 0.4, if this will still do it. That's where it failed. So it seems like the rule of thumb is it will turn up to the distance from the center of the profile to the edge of the profile. Does that rule make sense? So let's verify. I could be wrong. Correct. Yeah, it works. If you're doing a circle, it will work with the same size radius. Let me try 0.49 and let's see if that works. So it failed at 0.4. If it fails at 0.49, we'll know exactly that that's where it fails. I mean, it is a mathematical thing. Again, it's like when the body interferes with itself, if it makes a turn and the body hits itself in the turn, that's when it'll fail. I will say, though, it looks like, yeah, 0.49 failed. So let's assume then let's see, before when I did the edge example, it failed quicker. It failed at 2 inches. I don't know if that was because it wasn't to the center of the profile or if because it was an edge. Here, let's play with it. I mean, it could be either. It could be both. Before we do that, while we have this sketch, let's change this to a box and see if this rule is still the same. I think it is. Yeah, right. Can everyone see that? So at the half, so even though you can think of it as the radius of it'll revolve through whatever the radius of the circle is if you're sweeping a circle. But if you're sweeping a square or a rectangle, whatever the direction it's turning, it'll sweep through whatever the measurement is from the midpoint to the edge. Does that make sense? So here, because it's a 1 inch by 1 inch square, the measurement from the center of the square to the edge is ½ inch. It sweeps through a ½ inch. Let me try this other edge thing. Where is it now? We had this. Let's see now that if we put, where is our sketch now? I'm now going to move the edge right to the center of this here. And so now let's see if we can sweep this and this. Oops, that's revolve. Yeah, keep in mind revolve and sweep look very similar. Sweep is like the snake. If we want to sweep this through here, again, if you want to select multiple edges, you start with a right click, selection manager. It should default to selecting multiple edges, but if it doesn't, this is the icon you want, these like 3 arrows. All right, so that seemed to work. Now let's play with this and see if we move this off, if that fails. You guys see that? So it was more robust when it had that point in the middle to follow. Now actually, this is what it is. It's because it is, here, let's move it a different way. Remember how I said when it's off, it sweeps it concentric too? It's because I moved it to the left, so it was sweeping it on the inside. So that's why I was failing at 2 inches before, because the 2 inch curve, how do I explain this? So do you see, I moved the body to the right, and now it follows the sweep because this curve is actually bigger than a ½ inch, right? Because it's following it parallel to this line and concentric to this arc. If I take this body and I slide it back to the left, the sweep is still going to happen inboard of it. So it's going to happen, it's like an offset sweep from this outside path. So by the time we offset our ½ inch to the inside here, it actually gets a lot smaller, right? So this is why this maybe needs to be 2 inches. And then the amount that it turns in here is actually going to be a lot less. There we go, right? So this is a 4 inch radius, but this turn in here is actually a lot smaller. What is this? We'll go to the outside. Our radius is actually 2.3 inches, right? Because it's offset from that path. So again, best rule of thumbs with sweeps. You want it to be to the center of your profile when possible. You can get away with cheating without it. Just be aware that it's going to follow it offset. It's not going to follow it exactly. So when possible, have it go to the center of your profile. When possible, have the sweep path start perpendicular to your profile. You need to say if your profile is on the top plane, your swept sketch should be on the right or front plane, and it should follow that vertically, that 90-degree relationship. And then whatever turns you have on your sweep path, they should be bigger than the distance from the center of your profile to the edge of the profile. If I had to like state 3 rules, essentially. Slightly more advanced, but just worth knowing, it is possible to sweep in multiple directions. Your path does not have to be 2-dimensional. So if I pull this edge here, I could, oops. Keep in mind, this has to be, if I am about to edit this, this fillet would still not be there because it's below it in the tree. So tree order does matter. In this instance, I need to drag this fillet up. Now I go to edit my sweep feature. I can go here, I can right click on this and I can say edit selection, meaning to say I want to add or remove from it. Now if I click this edge, you'll see that the sweep now can happen in 3 dimensions. It can go up, turn left, and go around. Slightly more advanced. You guys probably don't need to do that for your handles. I mean, you could. It would make it interesting and have like an extra bend to it. And there are fancier ways to do this other than how I've done this with an edge. But more often than not, when I work, like this is a much quicker way to get a sweep path that I want, is I literally build a body and with edges that I want for that path to follow. There's like things called curves, where you can like create 2 sketches and blend them together with a curve. There's 3D sketches. So again, just like Photoshop, there's a million different ways to this end goal. This kind of example, like quick and dirty example I gave you guys by building this dummy body to serve as an edge for us to sweep along is perfectly an acceptable way to, like, if you're trying to do a very complex edge or sweep that you want. Does that make sense? Are there any questions about anything? So what are the 3 rules that we talked about? Yeah, path should be perpendicular to the profile. Yeah, equal or bigger. Yep. And then, no, the last one, it's, let me see if I can give you guys a clue. It's relatively basic. Yep. Ideally, the path is to the center of the profile. Just, again, best practice. It works without it, but that's best practice. Cool. All right. Let's work together, and then we can take a short break. And we'll capture lofts afterwards. All right. You know what? Whatever. I'll save this. Why not? So if everyone wants to create a new part, and I wish I had, well, no, I don't need a ruler because I have it. So yeah, file, new, and parts. I've like defaulted to working in inches, so I don't know. Here, let's see. I forget what I defaulted this template to. Just checking. It is inches. Okay, so yeah, if you're using my template, you're in inches. If for some reason that, I think you guys already know this, but if you ever need to change your units, you go to the gear up here, you go to document properties, you go to units, and you switch it to IPS, inch pound second. But if you use my template, it should already be in inches. All right, so if we're trying to make, after the break, I'll show you guys how to make this like more, I don't know what word to use here, organic, like soft, flowy surface handle. But right now we're going to demo, I'm going to just demo this basic swept handle, like a slightly more typical, you know, whatever, however you want to put it, door handle that you might come across. So in this instance, we want to start with a couple things. So again, just for the best practices of getting used to the master sketch. Again, the caveat here is sometimes with something this simple, this handle this simple, you probably don't need a master sketch for something that has like a tree that's like 4 commands long, but always good habit to get into it anyway. So let's start by making our profile. So I'm going to take the top plane, and I'm going to say Alt-S to enter my sketch dialog, or you can always sketch this or click on this icon up here. And now on a very basic level, if we want to keep this simple, I hit O to get my circle drawing tool. And what I want to do is I want to make my circle on the origin here. This is something, I have your grades from project 1. I'll hand that out at the end of class, but that's one thing that I thought I emphasized, but maybe not enough. The origin is incredibly important, guys. That's this little red dot in the middle here. Your sketch should always be on it, and things should always reference and dimension from that point. This is this is like the one fixed point that you should really only have in your sketch, as opposed to using an anchor, right? We talked about how that's a good crutch, but really not best practice to use consistently. So in this instance, I am making a circle. I'm clicking on the origin and dragging it. That's just how circles work. When you make them, it starts with a center point that you drag away from. As a quick side note, if I'm making a square, a rectangle, I have it default to corner rectangle. That's just what I'm used to. You could have center rectangle where it works the same way, where you can click on that center. I just tend to use corner rectangle. That's what I'm used to. And in this instance, if I were doing a rectangle, I would make a construction line across the center and set it coincident to the midpoint here, which I realize it would do it for me if I had the center rectangle, but I'm not always making a rectangle from the center. So anyway, always very important to go to the origin. I'm selecting it here, I'm drawing a circle. General good design rule of thumb for handles. Handles tend to range from 1 inch to 1.5, all right? So you see 1.5 inches on like fitness equipment, where maybe it's like, this is admittedly sexist, but if you have like these big strength machines that tend to lean more masculine, you get a bigger profile for the handle, because typically if it's like made for athletes, they're probably bigger people, so they're skewing bigger on the law of averages, right? I would say the kind of sweet spot for a handle is like 1 1/8 to 1 1/4 inch. So pretty safe rule to follow. So in this instance, like here, I might make this I'm going to make this 1 1/8. Now you don't have to do this, but what I did on my other handle, I put just kind of like if you guys want to just stop with a 1 1/8 circle, that's totally fine. If you want to do something like this, where you have like a slight arc to it. So what I'm doing here is I'm going to cut my circle. So I drew a line across. This is to hold my arc. If I did just an arc without a line, there's nothing guaranteeing that that's horizontal, right? Like, do you see how these 2 points, that's an exaggeration, don't relate? If I were to just judge this by eye, there's a good chance they'd be off. If I take a line here and I tell it to be horizontal, or if I draw it and if I draw the line to begin with and I see this little yellow box appear with a horizontal line in it, the little box right now there's 2 little yellow boxes. There's one with a green dot, that's telling me it's coincident. There's one with a straight line, that's telling me it's horizontal. If I click now, it will give that line both those properties built in. I don't have to create them myself. So by doing this line and having that horizontal built into it, I am keeping my arc horizontal in relationship to itself. I'm going to change this line to for construction. I'm then going to use my trim tool by hitting T, and I'm going to cut out this part of my circle. Again, you guys don't have to do this. My reasoning for this is now the handle's going to kind of have a flat face. It's going to look a little, it's just a design choice, really. It gives you kind of like a flat interaction. It makes the handle look less massive, but it still has that kind of comfortable curve on the back for when my fingers touch it. The diameter of this arc doesn't really matter. But one way that I do this is you can like just dimension the height to the center of the arc. You can dimension the curvature itself. But here we could also make this an 1/8. I mean, you could also, maybe wouldn't hurt to define like, where this is also. So again, if we go off of my rough rule of thumb, I could take this tool here, this point sketch at the top. I could drop this. It wants to anchor to these vertices on my circle. It gives me these like anchor points, top, left, and center. I could then dimension from this point to here, and I could make sure that this is an inch, right? Because I said that's the low end of what a handle is. You can always tweak proportion. Let's say I want this to look a little wider, right? You can always kick this initial measurement out to 1 1/4 inches. And really, you guys are welcome to choose your own dimensions as we work on this. As long as you're within the range. So I realize I'm kind of jumping around and flying if you guys want me to repeat anything. So, okay, we started with a circle on the center of the origin that we made 1/8 of an eighth. I would say that's the bare minimum to follow along with this demo. If you have that, you're good. If you want to follow along with what I have, I drew a line that was horizontal, and that's where I cut my circle. I put a slight arc. My design reasoning for this is just so the handle looks less massive. It has a little bit more of a flat face. It's just it's more of an aesthetic choice. Where there's the ergonomic aspect, where the fingers kind of wrap around the back, that's where I want my curve. I define my overall depth of my handle. I defined it to be 1 inch because I kind of said general rule of thumb for handles, that's kind of the low end. Again, it's a general rule of thumb. You could totally get away with a handle that's a 1/2 inch thick. It's just gonna, it depends what you're going for. And then just proportionally, I wanted my handle maybe to look a little bit wider. I went to 1 1/4 inches. Depending on how this looks when I put it into my microwave, there's a good chance I'm going to come back in here and adjust these things. All right. So when you have those things, yeah, Alexis. Yeah. So that was a good question, Alexis. So if you don't have these lines in here, oh, okay, my dimension tool is finding it. Let's see, if I hover over it, if you hover over a line, so it's orange, you'll see that this now appears. Let's see if I can select it. Say that again? It worked? Yeah, so it looks like you have to hover with it. I don't know why that is, I'll be honest. I tend to, you'll notice now that I'm on my line tool, not my dimension tool. The minute that I go on my line tool, like it appears right away. And in general, like I think it's a good idea to have a line that does this, right? It's top to bottom for construction. I'll do this frequently in my sketches. I'll have a line just so that I have these points to pull. And I mean, the other thing with this line, really it is best practice, I think, to drop this line in there because now I can just dimension this line overall. And now it's like, so now there's a couple of things that's defining the sketch. We have the center of the circle is the center of the circle is coincident to the origin. We have the overall width, front to back depth being 1 inch. The only thing that we don't have defined, or that I no longer have defined now is how much I want this curvature to be. And I think I initially had that at an 1/8 inch offset. But again, it's all arbitrary, right? I could change this to 1/4 if I wanted. All right, so that is our master sketch for our profile of our sweep. Does everyone have a profile they're more or less happy with? Again, in this instance, I would advise against, I would advise to keep corners. Don't try and sketch your fillets in here. So now I'm going to quickly look at my microwave that we made in class. And I'm just going to pull a measurement in here. I'm going to look at my master sketch. I mean, the microwave's sitting behind me. I don't have a ruler with me right now. But if I hit Alt-M, I can get my measure tool. And I can see there's 9 inches in between these two features that we have going across the microwave, this kind of like ridge here. So I know that I want my handle to be less than 9 inches tall if I want it to happen between these two features, okay? So sometimes, you know, it is common to work in SolidWorks with some notes by you if you need to write dimensions down. But anyway, so on this right plane, I'm now going to make the sweep that I want my handle to follow. So again, we typically want the sweep profile to be perpendicular. So the first thing I'm going to do, okay, so sorry, I'm going a little bit quick here. So let's exit out of that sketch. And I realize this is one of the most confusing things in SolidWorks. Am I in a sketch? Am I out of a sketch? Again, the way to check is if the sketch is black like this, you're in the sketch. Sometimes SolidWorks will do funny stuff where it will turn gray even though you're still in the sketch. That's happened to me. That does happen. I don't know why. The other way to check is up here on the right if you have this kind of like exit arrow in this red X. Okay. So make sure you're out of that first sketch. We're now going to create a sketch on the right plane. So I'm assuming your first sketch was on the top plane if you're following along. On this right plane, I'm going to create a new sketch. So I'm either going to hit Alt-S or click on this here. This instance, I'm going to say Alt-S. Now the first thing I'm going to do is, again, the origin is always, it's the most important aspect. It's kind of like the fundamental building block of SolidWorks. It's where everything starts from. I'm going to create a line that goes vertically down from this origin. And again, to illustrate for you guys, when I have this line going down here, well, okay, a couple things first. How do you know you're coincident to the origin? When this little yellow box appears, okay? And the origin turns orange or red. There's like a little dot there. If I click on that, I'm now coincident to the origin. Now, when I go vertical like this, and this yellow box appears with a straight line in it, when I click everyone's line and hit escape, everyone's line should be black. That means that it is defined as a vertical and coincident to the origin, because that's how, those are the 2 clicks we made. So that's how you tell it where you want to be. Correct. I did decide to pull mine down then above. You can always drag this back and forth. My reasoning for that is I want my angle to be arcs. You could, if you want your angle to be straight and then turn, you could start with a straight line. I'm building my angle with a slight arc to it. What this line does is now if I create an arc or a spline, and we'll probably end up using a spline, but let's just start with an arc for now, or at least now for my explanation. Now I have a line to make this tangent to. So this arc is tangent to this line. This line is perpendicular to my profile, so now this gives me a good start to my sweep. If I don't have this line and I go straight into an arc or if I don't have that line and I go straight into a spline or a curve, even if I try and judge by eye, so here, let's say I want to be normal to my sketch. Like, you can always judge by eye, but I mean, you're on a computer, you may as well, like, right? Like, how do I know that's perfectly straight? It might be close enough, but it's always better to literally tell it, I want it to be perpendicular to that sketch. And again, one way to do that is with a vertical line here, and by telling this spline to be tangent to this. Okay, we're not quite there yet, so I'm going to delete my spline. So everyone should have a vertical line down here. The next thing we want to know is how far offset we want, like, how much arc do we want our handle to have? Meaning to say, or like, how much gap do we want from the microwave face to the bottom of the handle so we can get our fingers in there? So one thing I'm going to do here, and again, this is another good reason, or another reason why it's good to have this line in our first sketch, is I'm going to select this line and I'm going to hit Convert Entities. If you don't have a line in there, the other thing you can do is you can get your line drawing tool and you can draw a line from the origin to the edge of your circle in your first sketch. This now gives me a point in space of like, okay, this is where the edge of my handle is, all right? I'm going to create a new line now. What this line is going to define for me, I'm going to define from the edge of the handle to this line that I just made represents the face of our microwave. So right now we're creating a dimension where we are defining the gap between our handle and our microwave face. Is everyone still with me? Again here, general rule of thumb, if you want to be safe, like an inch is too close. You can get away with an inch. I'm going to grab a ruler, turn our break, and see what this is. This is probably like an inch and a quarter. But typically an inch and a half is safe. 2 inches is good. You could get away with an inch, but it's like, you know, people's knuckles are then touching the door. People with larger hands that's going to be an uncomfortable feeling for them, right? It's never fun to feel like your fingers might get stuck somewhere. So again, just general design measurement. So in this instance, I'm going to start with an inch and a half because that's like ideal. We'll see what it looks like. I'll tell you now, it's probably going to look massive and like sticking out too far. So we might come back and tweak this down a bit. The other dimension we need, so I'm going to pull another dimension now from the origin. So I'm going to hit D for dimension. I'm going to hover over the origin until it turns orange. I'm going to click on that. And then I'm going to click on the top of this line. And I'm going to pull, you'll notice that the dimension sometimes wants to go at an angle. I'm going to pull it so that the lines are horizontal. This represents half the height of my handle. And I remember it wanted to fit within 9 inches. I know that my handle is actually, how do I phrase this? Because I'm dimensioning to the center here, or because the sweep profile is going to start in the center, I know that the handle is going to end up being slightly longer than where this point is. So instead of picking this to be half of 9 inches, I'm just going to set this to be like 4, so that we're comfortably within 9. Is everyone still kind of following along? So now a very simple thing to do, hey Josh, welcome. A simple thing to do would be to create an arc from this origin to here. And this would give us a very simple arced handle. And for now, really, that's good enough. If anyone, and I'll explain this and then I'll explain the spline. So I hit A for arc, or you can click here. I select the origin. I select this point up here of where it's where we define this point in space. I now click on this arc and this line, and I tell it to be tangent. Yeah, and then 90. I am a little confused. So I have no angles in mind. Are you talking about degrees? So right now my arc, you'll see it's black. My arc is defined by a couple things. One, it's tangent to this vertical line, so it's normal to the profile of the handle. Two, it's coincident with this point in space. This point in space is defined as being 4 inches higher from the origin and 1.5 inches further from the edge of the handle. So I have no degrees defining my arc. So if you guys look at my sketch, you should see that you have the same amount of black lines as I do. If you don't, something is wrong. So here's what. Anytime you guys have a blue line, try that. The way that it moves, that's what's not defined. And what's not defined for you here is that this dimension should go to the origin, not to the edge of this line. Or no, not necessarily the origin, sorry. This line was not coincident. You want to make this line coincident to this. Or this point here. Oh, I'm sorry. There you go. Okay, good question. Guys, I misspoke when I gave you guys advice here, let me tell you. So I'm gonna mimic, this is why it's good to always ask questions. It helps me catch things. I appreciate it. I'm gonna edit my sketches here so that I have exactly what Annette had, and we're gonna correct this. So let's say again, this is another good reason why it is good to have these vertices to dimension to. But I'm just gonna delete this line, okay, and pretend like I don't have it. I'm instead gonna grab a point here. I'm just gonna dimension this to be 1 inch. And again, like I know I'm a record, but there's a million different ways to do things. There are reasons for best practices, though. Okay. So if this is my sketch here, right? I think this is what Ineb did. You drew a line here. You clicked on your circle, and I told you to make that coincident, which that was my mistake. It's not coincident, okay? So this line, at this point in space, if I select this and this, and I tell it to be coincident, all that I told it to do, how do I phrase this? Because this is an arc, right, and it travels in a round, this line is coincident to that arc, because that, in relationship, if I look at the side view, this is what the point sees. You guys see how this arc right now is a gray line, essentially? That's what the point sees. So all that I told that line to do is to be coincident to a horizontal line on the origin. So that means, like here, if I take away the horizontal aspect of this line, I'm just going to use this to make a point. Okay, right now the lines, this is a line on our side view. It's angled up. If I take this point and I tell it to be coincident to the circle, this line is going to snap horizontal. You see that? And that's because all that this line sees of the circle from the orientation of this sketch plane is that it's horizontal, right? It looks like a gray line to it. So now it just slides this way. So I misspoke. The relationship is not coincident. The relationship of this point in space to this arc is what's called pierce. Pierce means that, how do I phrase it? If this circle, let's say that this was an extruded surface, okay? Imagine this being like a like the edge of a water bottle, right? Like imagine a clear water bottle. That's what this orange line is currently representing. I'm telling this line, if this line is a pin, where it pierces, where it crosses that face on that water bottle is where that point exists. So when it's coincident, it sees the arc as a flat line because that's all it sees from the orientation of this plane, right? When you tell it to pierce it, it looks at specifically, sorry, I don't know, I'm struggling with this. Where this arc literally passes through the right plane, that's where the point goes to. That's the best way to phrase it. So here, I'm going to turn this right plane on. We're sketching on the right plane here. I'm going to make this visible. So you guys see how this is like this light blue? When I took this point here, I'm going to remove both of these definitions. If I tell this point to pierce this arc, it's going to look at where this arc touches this right plane. So this yellow arc is passing through this blue right plane. If I look straight down, right in the middle. Does that make sense to you guys? Okay, I'm still seeing blank faces. Yeah. Okay. So here's another thing that might happen. I still think, based on, if I may, based on the looks on your faces, that my explanation of Pierce may not be sufficient, but we'll get back to that in a minute. Sometimes, I don't quite know how you're getting it, but is this what you were seeing? So if I select this line here, and if I then select this line here, because I selected two lines and not a line and a point, it's giving me an angle dimension. Does that make sense? That's likely what happened. Now let's see if I can mimic what you had with two lines and a point. Sometimes what happens is if you are, okay, never mind. I was going to see, like, sometimes you drag around and wait long enough, SolidWorks may be like, oh, maybe this is not what you want. Maybe you want it to be an angle. Like it's trying to be helpful, but it's doing the opposite. Yeah, you want to, if you're getting an angle, it's likely because you're selecting two lines. Yeah. Oh, because it's not pierced currently. It was just part of my example. Yeah. I don't know, I was going to take another stab at explaining piercing. Again, it's where this arc, okay, so our sketch right now is on the right plane, right? Everyone understands that. It's like a piece of paper, right? And again, we have three pieces of paper. We have the paper on the top, we have the paper on the right, and the paper in the front. This, again, if all the right plane cares about, whoops, is not that view. All the right plane cares about is this view. So all that it sees of this sketch right now is two straight lines. In fact, I can demonstrate that by if I take these lines and if I hit convert entities, they come in as straight lines because that's what the right plane sees. So it is not enough to define this as coincident to this arc because it sees it as a line. It is better to define it as a pierce point. And the pierce point, again, is where the arc crosses the plane. So again, this arc here, there's only a single point in space where the arc and the plane intersect. And that happens to be right in the center here, which is where we want it. So again, I'm going to select these two, I'm going to hit pierce. But again, hopefully you avoid this mistake in the first place by doing best practices and having a line drawn in the middle of your first sketch. So that's all making sense, hopefully. That's the best I can do to verbalize that. But yeah. Okay. So okay, we talked about many different ways to get this offset. That was a deep dive into pierce, good thing to know. Again, pierce is useful when you're defining to like another sketch. Again, let's see, I wanted this to be 1.5 inches because that's ideal. So now, as the last thing I'm going to do, I'm just going to go and like double check. Actually, no, whatever. I'm calling this done. I'm saying this is fine. So I guess I did mention that I was going to, an arc is good enough if you guys want. Oh yeah, okay, this is worth mentioning, sorry. If you want to try using a spline, you could do that. So what I'm going to do, I'm just going to make my arc for construction just so I have it. So here's another handle rule of thumb. Typically, handle diameter is anywhere from 1 inch to 1.5 inches for comfort. Somewhere in the middle is best. Typically, you want spacing from the base of the handle to the face that it's attached to be at least 1.5 inches. If you can do that, that's ideal. The next measurement that's important is how long is the handle. Typically, you want about 4 inches. Again, these are all like ideal measurements. They're by no means set or fixed. So what that means is, if I just throw this in as a reference, I'm just going to. So we know that this is the center of our handle. So if we want a hand to grab that, we know that we want at least about 2 inches of flat here. So honestly, that arc looks pretty good, especially at that 1.5 inches, right? But let's say that, you know what, this is falling away a little too fast. What I'm going to do, and you guys don't need to make this 2-inch line unless you want to. It's just there for reference to make it point for you guys. What I'm going to do, I'm going to make a spline. So you can either do that by clicking this like N shape up here, or if I hit S, it brings up some like sketch options. This should be the same for you guys. And click on spline. So when I make my spline, I'm going to click on my origin, and I'm going to click on this point up here, because that's again where I want it to go to. Now again, splines are really tricky. They're hard to define. You don't want to have too many vertices on them because it's going to make them messy. I like to keep my splines to 2 vertices whenever I can. And that's essentially what I've done here. It looks like we've created a straight line, but now you'll notice if you click on it, you have these little arrows on here. So everyone probably has a black straight line, but then if you click on it, it should turn yellow. You should see these 2 little arrows. I think you can get away with just selecting this vertical line down here and your new spline that looks like a straight line and just telling them to be tangent. And you should see the line jump. Does that work for everybody? Yeah, for sure. I'll start from the beginning. So I'm going to hit S to create a spline. I'm going to click on the spline tool. I'm going to select the origin, and I'm going to select this point in space that defines the upper part of our handle. I'm now going to select the spline and the vertical line, holding control so that I have both selected. I tend to forget to mention when I'm holding control down. Anytime I select multiple things and they all change color together, it's because I'm holding control down. It's how you select multiple objects. So now that I have both of these selected, I can now define a relationship on the left here. I'm going to say I want them to be tangent, and that's going to snap my spline into tangency with this vertical line. And again, it's so that it's perpendicular to the profile that we eventually want to sweep. Now what I'm going to do, I'm going to select, you'll also notice this arrow turned blue. It was gray before. So now it's active. I'm now going to select this arrow, and I'm just going to drag this spline up a little bit. Again, you can be as aggressive as you want. In general, as a rule of thumb, I don't like, do you see the gray arrow at the top of my screen there? I don't like this to go more than, let's see, I'm going to describe these two arrows as having a 90-degree relationship right now. They shouldn't have less than 90-degree relationship. Specifically for a handle, I don't know. I just think it's going to look funny if the handle goes wide and then comes back in. I guess that's a design thing. Anyway, I'm just going to drag this a little bit higher up, a little bit more arc than what I had originally. And then I'm going to exit out of my sketch, again, by clicking up here. So these are my two master sketches, right? Does everyone have this? Any questions? You can. I left it in as a for construction line in case I needed to revert back to it later. I don't know. If you have it in there already, just change it to for construction. I mean, honestly, you don't even need to. You can leave it in there. Because this is our master sketch, we're going to be copying lines over anyway. All right, so I'm going to exit my sketch out. And again, here, this is just for best practices. We're going to take the top plane here. I'm going to create a new sketch on it. So I'm going to hit Alt-S. And now I'm going to, so again, sorry, let me slow down. So we want to take our top plane and we want to create a new sketch. So again, I'm taking my top plane here, and I'm clicking on my sketch icon here, and now you should see a new sketch appear. Now I'm going to select our initial profile. Again, select on the circle, hold down Control, select on the arc, and now I'm going to click on Convert Entities. And you should see them change to black, and you should see this inside turn to blue if it's a closed profile. If everyone has that, you can exit out of your sketch. If someone's having issues, raise your hand. I'm happy to come look. Basically, we copied this front sketch here. Yeah, and just the arc. Yo. So, okay, so we have this converted entity. So now on this side view, I'm going to now select my right plane here. And now I'm going to make another sketch. And again, I realize this feels convoluted. Trust me, in the grand scheme of things, when you have complex models, master sketches make your life way easier. So here on this new sketch, right, you should see now a fourth sketch dialog here. Here, all we want is just this arc. That's all we want. So whether you went with the arc or whether you went with the spline, I'm just going to click on it till it turns yellow, and I'm just going to click Convert Entities. It should turn black, and when you have that, you can exit your sketch. Right, so good question. These are our two master sketches. These are new sketches we're creating for features. Yeah. So I converted entities to spline. So I'll back up. So I have my profile. Now I want my sweep path. I'm going to take my right plane. I'm going to create a sketch on it. So you should see a new sketch appear. I hit Alt-S to enter the sketch dialog. I'm now going to select this spline. And I'm now going to click on Convert Entities. And then exit out. I'm literally just copying it one-to-one. Again, I acknowledge that it's somewhat convoluted to do it with a model that's this simple, but it is good practice to get into for the long run. The way that SolidWorks works is as you build features, they reference other things in your model. Inevitably, you're going to want to change some of those features as you're adjusting your model. The more that you can point to one source and not other sources, if you happen to delete another feature that's no longer needed, the features that are pointing to the master sketch will stay constructed. They won't disappear, they won't fail. So that is the sole reason for the master sketch. It gives you one home where you point as many features as you can to, so that as you make changes, your model is robust. You get less errors. It fails less. It allows you for more changes. And then if you set your master sketch up correctly, so that you know what changes you may need to make, it allows, like for example, if we look at this, right, as a microcosm of a master sketch, I have the critical information in here. I have how high I want my handle to be for my microwave face. I have how tall I want my handle to be. I'm probably going to drop this in my microwave. We'll look at it, and I may have to make changes. And this is when I have to make that change. If I'm like, you know what, it's standing off a little bit too far, I can just come in here, type 1.25, and provided it's still referencing this, everything should rebuild. So again, that's the reason why we're doing this. So we copied 2 sketches. This is, again, where it can get tricky of what you select. So now here we're going to make our features. So now we click on Sweep Boss Base. It should be up center. Let's see if you guys have Command Manager. Let's see if I can find where it is. It's kind of in the same place. Sweep Boss Base. So again, really when you do a sweep, there's just 2 things. It's asking you what the profile is and what the sweep path is. Again, as a reminder in the property dialog, whatever is blue that's highlighted, that's what it's asking you for. Okay, good question. Yes, you should exit the sketch. Correct. You should be in no sketches right now. So we're going to click on Swept Boss Base. So now this is highlighted. It's asking us for our profile. Here's where it can get confusing. It's going to be tempting to just walk over, like go over to your view here and just click on one of these things. I remember from memory that we created a copy of our profile first. You can also hover over these 2 sketches till you see your profile turn orange. Again, it should be of the 4 sketches you have, it should be one of the last 2. So when you have that profile, you want to click on that. And then same thing here. When you want to pick your path, you don't want to pick your master sketch. You want to pick the copy, in which case it's just the spline. Absolutely. As much as you can. I'll state it again, which is good. Repetition is good, questions are good. If you're working on a model, and here, you know what we'll do at some point? I mean, this is getting long now. We'll wrap this up. I'll start the next section with looking at one of my more complex models, and we'll look at my master sketch and how that all worked out. But yes, the best way I can verbalize it, the reason you want to do that, SolidWorks features build on each other. They build on sketches and stuff. If you accidentally make a sketch coincident to the edge of a body, and then later in your redesign, you put a fillet on that edge, or you delete the body, or the body changes and that edge no longer exists. Now that anything that was pointing to that edge is going to fail. You're going to get a red X, or you're going to get a yellow exclamation mark. It's SolidWorks saying, hey, I was looking at this edge and it's no longer there. What do I do? So if you get in the habit of having one sketch at the top of your tree, and you point as many things to that sketch as possible, now when an edge disappears, if you're pointing to a sketch as opposed to an edge, like, it will stay robust, it'll stay there. And then ideally you have enough knowledge of what you want, where you want to go, that you have the features in the sketch that you need. Okay, so good questions though. So hopefully we selected our copied profile and our copied path. I'm going to click on my check mark here. And you guys should get something that looks like this. Yo. All right, and I just asked another good question, so I'm going to go through this again real quick. I'm going to enter my Swept Boss Base. Right now it's asking me for a sketch. If I look at this here, I guess it let me select it. I don't know why it wasn't letting you select it. But if you start clicking on these sketches here that are visible, you might accidentally select the profile. You may accidentally select the master. What you want to do, you may not see a tree here, but anytime you're in a property dialog, if you click on this up here, you can see, or more specifically this arrow here, you can see a copy of your tree that's going to float over your white window screen here. So my suggestion when you selected these was to select directly from the sketches of this tree here. So here we have our profile. Again, I'm hovering over it, I see it turns orange. Here I want my path, I select this. Okay. The next thing we're going to do is on this right plane, we're going to take this line here. And this is again from our master sketch. This represents the face of our microwave. So I'm going to convert entities on that. This is a cut that we want to make to our handle. Yeah, sorry. Good question. Yes, okay. No, these are good, guys. I do tend to glaze over some of these things. We're making a brand new sketch. So I'm going to go on my right plane. I'm going to get out of my command manager. I don't know what you guys prefer to see. But I'm going to go on my right plane. I'm going to create a new sketch. We're about to create a cut because we want our handle to end where our microwave face is. So I'm going to go to my master sketch here. I'm going to select this vertical line, and I'm going to convert entities on that. Now, anytime you convert entities, you copy something over, you can always like drag points. I guess I shouldn't say always, but typically you can drag points. So I'm going to grab this point here. I'm going to drag it up just to make sure that it's fully piercing my handle here. It turns that point to blue. The line, it's still coincident. SolidWorks is still telling that sketch line to be on top of the master sketch line. But now I've said, hey, I actually want this endpoint to be higher up. Now, while you're still in the sketch, you don't have to exit out. You can click on Extruded Cut. Now, in our Extruded Cut property manager, you'll notice a couple things. Right now, it's blind, which is trying to do it as if it were a profile. We're going to change this to, say, through all both. And now this changes the cut to be kind of like it changes the line to be like a knife edge. You'll notice that there's a little arrow in here, this arrow right there. This is what is going to get cut away. So if this is pointing at the main part of your body, it's pointing the wrong way. You want to go over here and check the flip side to cut box. So again, you want to change this instead of blind to through all both. You want to check, you want to make sure that this arrow is pointing the right way what you want to cut. And then you want to hit your check mark. Explain line. Blind. Blind is, it typically refers to a profile, so it needs to be a closed shape. So a four-sided square, a circle. Blind tells the cut how far to go in a distance. So you can say, I want to cut a circle profile 1 inch deep. So like, I don't know where the word blind comes from. I'm going to guess that it's kind of like it blindly follows what you tell it to do. Like it's kind of like a blind cut, like cut it 1 inch. Through all means like the difference between through all and through all both. Through all only goes one direction, I believe. Okay, no, I'm wrong. Okay, my anticipation was that through all was only going to go to the right or the left and give me an error, but I guess I'm sorry, I don't have a good explanation for that. Through all and through all both works best when you have a flat line that you want to use as a knife edge. You could have like, or sorry, it doesn't have to be a flat line, it can be a curved line, but you have a single line. Through all is what works best. Does that answer your question on blind and through all? Okay. More often than not, typically, like, I know not all of you were here for this microwave demo last time. But when we made this cavity, we made this box first. This cavity we did with a blind cut. Here we had a closed profile, and I told the cut, actually no, sorry, I did an offset. Here I could tell it to go 4 inches. The reason that we did an offset is I said, you know what, I want it to be an inch away from this back face. So SolidWorks kind of knows, right? Because this is a closed profile, there's a lot of options here. Let's see, through all both. Yeah, there you go. Okay, wait, here, let me go back. If I tell this to go through all, you'll notice that it's just going to blow away whatever's to the right of this. When I select both, another arrow is going to appear pointing the opposite way. I think because we had a straight line and it happened to be in the middle of our object, SolidWorks, again, it makes a guess of what I want to do. and knows that if I just do through all, it's going to fail, so it cuts it both ways. I don't know, that's my best explanation. So yeah, there's a lot of options here. Blind, again, it's just like an exact amount. Through all is just like through everything. In this instance, we did offset from surface, which again, what I care about is how far it is from this back wall, and in which case I told it to be an inch. So that's an example of blind and other options. Okay. So I'm noticing now, jumping around, that we forgot to save this. This is always the most important thing. So file save as. I'm going to call mine mwave sweep handle. This is going to be RO3. All right, so does everyone have something that looks kind of like this? So you'll notice, right, that the handle's cut short. One way to fix that is now we can go back into our sweep and we can edit this sketch here. So again, we want to go into our sweep here. We want to find our swept profile and edit that. And like I said, even though you have a converted line, you can always click on a point and drag it. Oh, yes, now we can. And honestly, that doesn't matter. That's another thing with splines, is sometimes they'll jump far. Like let's say it does jump that far. It's not the end of the world because we end up cutting it, right? You can see it ends up going further than what we want. If that doesn't work for you guys, here, do this again. I'll do this again. I had to like click on it and drag it a bit. It gave me an error and then it let me drag it, or not an error. It kind of said, so I click on this point and I guess it let me drag it right away that time. The first time it said this point is fixed, I had to like pull on it a couple times. If it is like getting wily like this, like kind of out of control, you can always just throw a dimension on here and just set it, set it back a bit. Not necessary, in my opinion, though, it's not necessary to do that. Yeah. Good question. So in the master sketch, yeah, that's a good question. My reasoning for not is because in the master sketch, I'm telling it where it needs to end. I'm elongating it for the sweep so that it gets fully cut. Right now, this point in space defines where I want this to end. The point in space represents the height of the rough height of the handle, because it's the center of it, and kind of the offset. So if I were to move, I guess one thing you could do, let's look at this. Well, if I delete this now, this is going to break my. You could, here, let me change this to for construction and I'll make a new spline and let's look at what this looks like. You could do it this way, actually, if you wanted. So instead of going to the end point here, I could in theory have a spline that looks like this. So I could have planned ahead better. Here's the best way verbally I can explain why I did what I did. It was just easier to do it that way. I dragged it. It's still pointing to the right. It's still pointing to the master sketch. It will still, if I go back in here to my master sketch, this is this sham, or this new one that I made. Not that it matters that it's for construction. But now if I take this and if I still, what's the word? Play with it, which I don't know why I'm not seeing my anchor point here. So I'm going to play with this one. If I still like move this spline and now I exit, it's not happy with that sweep. This is what it doesn't like. Okay. Maybe I changed it too much. It should rebuild. It should work. All right. Maybe not. Okay. Wait, let me. So maybe then to your point, maybe that should have been done in the master sketch. It's easier to drag that point longer. Let me go back here. Let me walk back through here and see if we can get this to work. Okay, let me exit out of this. It's still currently unhappy with me. I'm just going to copy this back over. Exit out, okay. So I'm going to do the same thing I did. I'm going to take this point and drag it just a little bit further. Exit out of this. I'm now going to go back in here. I'm going to modify my master sketch a little bit. I'm going to drag it back. Let's see if this works. Okay. It worked that time. I don't know what happened last time if I messed it up too much. Let's play with it again. I'm now going to drag, oh, you know what? I think it was dragging this point is what goofed it up. Let's make it extreme, see if this works. So now it's not happy with me. So it may only work. I'll be honest, I'm not sure if it's the sketch that's failing or if it's the sweep that's failing based on these changes. But the point I'm trying to make is you can still drag it a little bit longer to get that cut, and provided the changes to your spline are not too extreme, it will still rebuild. You bring up a good point though. If you're willing to take that time and it's like, oh man, I made a mistake, I actually need this to go further, you could do what I did the first time, which is to go into your master sketch. Unfortunately, like, this is already coincident to here. I don't know if I can select this point. One thing I may be, like, it would be better to plan that from the beginning and make a spline that goes from this point, and instead of ending here, it's coincident with it, so that it is longer than you need it to be. You don't need a construction line. I could directly within here take a spline, select this midpoint, click out here, and just select this point and the spline and just tell it to be coincident. Right. I already have those 2 dimensions. I mean, you're right. Again, it's great questions. Like, there are certain things I do sometimes maybe out of bad habit. Again, my reasoning for dragging that point, it was just an easy fix to get my sweep to be a little bit longer so I can cut. Splines within reason, as long as you don't modify, like as long as it doesn't overextend the sweep, it should work in how it translates, and allows you to make those modifications. Okay. Okay, let's wrap this up. Does everyone have something that looks roughly like this? Okay. What we're going to do now is we're going to add fillets to our edges here. Again, if you have like a full round, that's okay. So I'm just going to make this a 1/4 inch. It doesn't matter. So again, what I did, I'm not in any sketch. I just click on my fillet tool here, and I click on these 2 edges. I leave all my defaults to whatever they are. I just change the value to 0.25. When you have that, you can click check. So again, I'll do it again. Oh, it doesn't matter. I made mine a 1/4 inch. Again, in general with fillets, it's like anywhere from like 0.1 to like, I mean, it depends what you're doing, but yeah, I don't know. So here I made mine a 1/4 inch. And now the last, this is also a new tool we're going to learn, but it's relatively simple. It's called mirror. Basically, it takes an object and it just copies it over about something, right? So here we have our top plane. This is only half of a handle. We want the same handle to be on the bottom of it. So I'm going to click on this tool here, it looks like two Tetris pieces. One's blue, one's white. They're facing each other. Click on that. So again, here in the property dialog, whatever is highlighted in blue is what it's asking you for. So here it's saying, what are we mirroring around? So here we want to mirror about the top plane, right? We want, the way we know that is like, you could also select a face. I don't know how else to verbalize this, but it's like, we want whatever's above the top plane to also be below it. So that's the face you're selecting. You want whatever's on one side of it to be on the opposite side of it. So this would represent the center of whatever object you're mirroring. And here it's saying, okay, what is it you want to mirror? You want to mirror a feature, a body, a face. In this instance, we want to mirror a body because we have the body built. It has a fillet to it. We could maybe mirror the swept feature, but I don't know if it's going to copy all these other things. So bodies are always the best default to select in general. Even though defaults to feature, bodies is more robust in my opinion when you're mirroring things, and is most often how I use it. So you want to select the body's mirror dialog. It's blue. You want to just click on your handle, and you should see a yellow other portion of it appear below. You can leave merge solids checks. You can leave all these checks. Once that's good, you can select the green check, and boom, yay, we have a handle. Yay. Okay, gotcha. Yeah, if you mirror the feature, not the body, yeah, exactly. It's probably going to take whatever that feature originally was and no extra commands to it. So it sounds like, Alexis, you were saying because your handle was elongated, it copied that elongated part of the handle. Gotcha. All right, cool. That's a lot of talking, a lot of learning, hopefully.